All right, so here we
That's
are,
okay.
live with our casual conversations. And today's topic we want to talk about is our thermal brick support system. And I think the first question we get asked is why why this thermal brick support system? How does it work? Where's the research that shows that it in fact has an impact on our thermal performance of our building? And I want to take that over to Jason to kind of elaborate more on that.
All right, thanks, Linda. So the thermal brick system is a projected shelf angle. In other words, the angle itself is pulled away from the building to allow for a continuous air barrier install before the lintel is installed, as well as continuous insulation. Standard shelf angles. There was a study done by RDH. Graham Finch published it. A standard shelf angle, depending on the wall makeup, it'll lose 37 to, I think the number 64% of the effective R value, because that continuous insulation is disrupted and that lintel is actually has continuous contact to the backup. So by projecting this angle out with a thermal brick system, you can switch to, I think, the next slide. Yeah, so right here it's showing 15 to 16% overall reduction in R value by getting that continuous insulation behind that lintel. So right there, on top of continuous weather resistant barrier with minimal detailing, easier installation, you're dramatically changing for the better the reduction in R value. I don't know about you guys, but that's substantial. That 24 to 28% change in R value. So no matter, I think it's also Graham Finch showed with a standard shelf angle, you have this disruption. You start noticing the effect of R value. What they do is they start throwing more insulation at these walls. They'll go up from a 2-inch insulation to a 4-inch insulation. But when that happens, now that lintel has to grow in length. So now they're increasing the size, increasing the amount of contact. So you're never going to catch up with insulation because everything just continues to grow. Now, by using a thermal brick system, you're going to go down in material, and you're going to be able to keep that wall makeup as efficient as possible without having to get too much material in there.
Yeah, I totally agree. So we make these in several different ways. And so I think that we will push this over to Mark to kind of talk about the different ways in which we attach these systems. And I'm going to turn that over.
Okay, thanks. So I'll get you to go to the next slide. So moving on towards the job site conditions and realities of construction, where this product would ideally reside in would be in your Division 4 specifications. So in adding this to your project specifications, you would want to include this in Division 4, the realm of the through wall details. So one of the best benefits of this particular product is the ability for the mason to start the installation of the exterior wall and control the starting point. So this would very much be a product that would be installed by the mason off of the wall, which is traditionally done with a cast-in-place system. You would see a miscellaneous steel contractor typically welding a shelf angle to an embedded. So right off the bat, the bricklayer is given full control of setting their lines and their planes for installing the brick, which is a good thing. There's also a couple of different options with the system in that we can use a fast bracket system, or as shown on the next slide, Linda, if you don't mind. The best and most adjustable version of the TBS is the shark tooth insert system. So that allows for both vertical and horizontal adjustment of the entire assembly. So this will allow the mason to compensate for any irregularities within the formwork. And it will actually require a little bit of coordination between the form setter and the mason trade, in that the shark tooth is going to have to be somewhat accurately cast into the poured concrete first. But if that's done well, what will happen then is, following the pouring and stripping of the form, the bricklayer then comes in afterwards and will start installing the shelf angle using the adjustable system. So I just need that slide advanced one more, Linda, to the second one. There we go. So there's a close-up of the shark tooth adjustable insert option in a cast in place application. So aside from the actual adjustability and benefit to the mason, I'll get you to go to the second slide. What the TBS also allows us to do is have better detailing for our insulation and vapor barrier, in the fact that we're now in an era where continuous insulation is a very common theme for design, for our values, and also the building envelope considerations. So we're seeing continuous insulation quite frequently in residential home building, where we have a rigid insulation on the outside of the stud cavity wall. And what that does with the TBS system is allowing the insulation to be continuous in one plane, that we're able to tape and detail all of the joints and seams in a much better and cleaner way than with the traditional method. So that would be a summary of all of those things that come into play with the trade on the site. So we're allowing for better adjustability of the angle itself, more control, the masonry trade, for adjustment and any discrepancies in the poured work. And then we're also able to detail our building envelope a lot better. And with that, I'm going to pass it on to Robin, who is next. He's going to talk a little bit more about something.
Do you want to go first, Robin? We were just going to talk about what it looks like in the field as far as a mason's perspective, potentially, because that's who's installing these, right, Robin?
Well, and in a perfect world, then yes, the pros to the mason doing the application are far outweigh the cons. But and after speaking with several contractors yesterday and the past few jobs that I've done, the structural steel person on a steel wall, which Mark was saying is typically done by the structural steel contractor. On a cast in place, you can get the masons to do it pretty common. And the main reason why they do it is because as you're coursing the wall out, if the mason has control of it, and when he's going to put his shelf up there, he's going to build his way to it, is what I was being told. And that way it allows you to be, so a mason's mentality is a finish work. And when you're building with the finish in mind, everything they do has to be judged by what the final looks like, what the final outcome is. When you're wrapping something in veneer, you've got a finish in mind on everything you do. That gives a lot better perspective for the mason to do it, because the steel guy is just putting the material up and moving on. His product, he's actually not judged off aesthetics. So in most cases where they do not put the angle in, there's a lot of cutting and shimming and having to fit brick into that system. So in a perfect world, yes. In reality, some of the cons, the main cons being that the competition is so strong right now, as far as everybody is trying to get the job and get low and get the job and get low. We would have to go in and train a lot of these masons on these metal studs to go in and put it into their estimate, because so often in this industry, masons take on more, and they end up kind of being, because they're that final piece, they end up taking on more and more and more of things that are outside of their scope. And in fact, when I was talking about it with one of them, he was very passionate about the fact that he said, I know I can already see it in 10 years. It's just going to be something that we're all installing. So there's definitely some training that would have to be done because it's not their cup of tea. Just in the bidding, just in bidding, and right now with the amount of competition, everybody's trying to get low. This is going to be something that a lot of them are in fear of, that the GC is just going to get it and try to work it in and say, oh, well, you'll take care of that because it's masonry. You and I and people in our industry understand that it would be more beneficial to do it, but it's still going to be a challenge.
Yeah. Yeah, you're
Uh,
so right.
so basically, I think that's on us to kind of help help them understand when bidding and estimating, but at the same time, it's kind of a market that's going to kind of dictate what they go after and how they go after it. Because if it bids them out of the job, that's going to be a whole nother issue for them. But yeah, most definitely, if the mason can put it up, it's so much more convenient. Everything's going to flow better. The scaffolds, they're in control of everything. They can work their way up to the angle. It's going to be a much better finished product. But at the same time, they've got to work around with whatever's going on, and every job is different, as you all know that.
Okay, so Shay, I want you to talk to a little bit about, because I was interested in the fact that you said some things are coming to New York, because currently there isn't anything in code that tells you you have to start using offset shelf angles. You need to start using thermal efficient ways of building. Like that's more of what's coming down the road. So what are you seeing from the New York perspective that you can add to this conversation?
Attending a presentation by John Straub earlier last year, and it basically pertained to a local law 97. And this local law basically states that, but starting in 2024 in New York City, all high-rise buildings are going to have to meet a certain carbon emission standard. This law was basically renamed the New Green Deal. So I did some more research on this, and I basically found out that there are two initial compliance periods. The first one being 2024 to 2029, where I believe they are trying to reduce carbon emissions by 20%. And then the second compliance period is 2030 to 2034, and that one's a little more stringent in the fact that they have to reduce carbon emissions by 40%. So my perspective on this TBS system is that it is a way to design for the future. And I know it's hard for people to invest more money now to wait a few years to see a return. But in my perspective, it's better to design now, you know, invest a little more money in the product now in order to see those returns 5 years, 10 years from now. So after doing a little more research, it uh, basically showed me that about 57,000 buildings in New York City are going to be affected by this local law. So basically what this means is even buildings that are being built now. So if you're a designer and you're building a building now and you don't design it correctly to basically comply with these new laws coming in, you're going to have to be going in 4 years and basically pouring, more time, more labor, more money into this relatively new building. So that's basically my take on it. And I know this only applies to New York City, but it's good for, the entire country to kind of take note. We all know how things go. One person is always the leader, and then people follow behind. The timeline could be a little scattered, but it is going to be coming.
Yeah, it just seems like while we aren't told we have to start worrying about thermal efficiency, we're all designing our buildings that way, right? And it just makes sense that if we're going to build to a certain R value, that your building is performing in that capacity. And that's what this system can help you do, is eliminate some of those major issues that you've got with thermal bridging, and how this can help then your project help deliver the performance that you want to see on things. So join us next week as we talk about and dive into a further conversation. If you've got questions, bring them, because we're going to have this open forum concept next Wednesday. See you then.